Okay. Good afternoon to everybody. Some technical notes before starting. First, for Italians only, there will be some calls for election, regional election in the next 2 weeks. In particular, the October 7th and the 14th, people coming from Tuscany, if I'm not mistaken, and Calabria. Okay, if you are in that position, you can ask me to have streaming. Okay, as they have to go in another region, 2 days before, 2 days after, we will assure that you will be connected in streaming if you need it. In case, please mail me. Okay. Second, next time you will start having practice with Professor Neri. I guess that in today or all the material will be uploaded. Material that you have to some extent have a view, just maybe give just a quick view, nothing more than this, because these are not cases, are very limited cases. You will practice on performance. Okay, and maybe you will see also which is the material.
Is there a problem if I'm not attending the next lecture because I will not be?
Don't worry.
Practice, is it mandatory or can I watch?
No lesson, no lecture, lesson or practice is mandatory here. So you can.
Be uploaded, I can rewatch.
Yeah, always. Second, just a check. Did you, my check on your check, did you check that all the materials is available? Books, in case you want to buy it, workbook, whatever. Please, if you have any issue, please tell me now, so we can act, okay? And second check, do you have any question about last lectures before we start? In case, okay, please ask. If you remember, we were speaking about performance, okay, and we were going through all of them. If sorry, I have to go here. If we entered the service performance. If you remember, just to. We say that service performance are seen as important as those related with cost and quality. So service is on the product that we are producing. We went through accuracy, wrong item sent, completeness, number of transportation we are making in order to complete one order. Availability, stock out, availability on hand about goods and items that we have in the warehouse. So if you have to provide things, goods from the warehouse, stock out is, or availability from the warehouse, is a good, to some extent, way of looking this phenomenon, this performance. Persistency of stock out, that is to some extent another very similar indicator of stock out, but still very important because stock out happens, but persistency means that you keep on having problems. And if stock out could happen, so the client to some extent is working on forgive, to some extent some unit missing, some orders that are not perfectly. If you keep on having stock out, it is that you are losing the client. And you are losing, to some extent, also your reputation. So it's much more important. Now, to go on in understanding other performance in terms of service, we have to understand better what is the lead time. The full name is total lead time. And this is the time that is elapsed, okay, from when we are receiving the order is issued up to the moment when, okay, this is ready to be delivered, or if the delivery is included in the service when the product is delivered to the client. Okay, this includes credit confirmation, because by the way, we're just going to accept the order only if the credit is confirmed. Okay, we release a production order. We say, okay, we can start producing. Or in case we are issuing a purchasing order in case we need something from external suppliers. This takes time. So, and this is this red part here. After that, we are to some extent losing time because we should wait for all the materials that we have asked for. But also, maybe we have to wait before starting manufacturing, producing. We have to wait for Q, because maybe the machinery is, to some extent, run for another lot, for another product. After that, we have the so-called production time. Here you can see that production time is only a little share of the total time. We will see next that in some production systems, production time could be more similar to the total lead time, but most of the cases is not. It's only a little share. Followed by some time that we use for inspection and final control of the production, time spent in storage, and finally for delivery. But even if we go into production time, we see that this production lead time, only this share, is not completely productive. Because this that is called production time, we are losing some time because we need to set up machinery in order to start the production of that product. We have this called manufacturing time, processing time. But also we are losing some time waiting for the lot. Most of the time, if you're after late, working late, you receive a cask, a pallet of pieces to be processed. You take the first one, you process it, and you drop it in another cask. Before the first one can leave and go to another machine, maybe you have to wait all the other 99 pieces that are in the cask before you can take the cask, the full cask, and send to the other machine. So maybe you have also some time that is called waiting for the lot. Plus, in case, maybe some control activity took place just after, because it's not just assembling, but take after in the cask of the 100 bolts that you work on the lathe, and you have this time for controlling. So in the end, now we will go into details on that, but only this little share of this one is to some extent productive. Now, to performance related with the lead time. Okay, lead time, here there are some specific dates. The date when the order was issued, the date when production started, work order, the date that was requested by the client, the date that you plan to deliver to the client. Okay, this one could be before this, but this user is more critical in this way. So the client asks for the beginning of the month, you plan for mid of the month, and in the end, the actual delivery time is at the end of the month. Okay? So here, looking at those data, you can immediately identify which is the total lead time. The total lead time usually is referred to the actual delivery date with respect to the date when the order was issued. So client to client. This is the lead time or total lead time. After that, some different lead time can be highlighted. For example, the planned lead time from here to here, the requested lead time here to here. And this last one maybe is the most interesting for us because the distance, time from the date of the order and the requested date is called requested delivery time or client delivery time, what the client would like to have. And in order to satisfy the client, we should comply with this one. Okay? So the idea is that we have to some extent compare this one with the actual delivery time. Very simple. Okay? Is it true, okay, that this one by far is to some extent, okay, what is needed, and this one is what we perform? To some extent, both of them, okay, are called promptness. Promptness is this is what we can deliver as performance. This is the promptness that is required by the market. Okay? How we are able to react to the order that is issued by the client. Not only, there is another performance that is punctuality. Because if we compare the requested date by the client and the actual delivery date, this is a delay that is experienced by the client, the wish and the reality. In that, we can, to some extent, separate within these two different delays. If you want, the client requests this date. You plan to deliver at this date 15 days after. You're a little bit like cheating, but in the end, this is what is going to happen because the request is at the beginning of the month, and when you issue the order, you know that the delivery date, you set it as mid of the month. But this is a planned delay, while the distance between actual delivery date and planned delay is something that is not planned. If you look at client, for the client, the idea is delay is delayed. So 1 month of delay. But to some extent, this is to some extent controlled by my management, my way of planning. This is out of control. So I have two completely different meanings. Okay, so you plan to be late, it happened that you are late. Okay? After that, please remember that you're late in both of the cases with respect to the wish of the client. Now, if everything is okay, not really difficult, maybe we can add another date up there. Agreed date, okay, or also called promise date. The client would like to have the product by the beginning of the month. You try to say mid of the day of the month, like the planning that you like to do. To meet the end, you say, okay, by the end of the first week of the day, of the month. This is the promise date. So you are shifting the requirement of the client in agreement with the client to so-called a promise date. That, okay, usually here is in the between the request date and the planned date should be. Again, is to some extent reducing in terms of quantity the requirements of the client. Is to some extent I agree to wait 1 week more. Please also remember that the wish of the client was to have it at the beginning of the month, and you agree with him with a week later. So you have always to understand what is the wish, the best ever for the client, delighted. If you get that date, you delight the client. The promised date, the planned date, generally speaking, and the actual one. Okay? Now, well, if we look at lead time, it's quite obvious that we can compare the total lead time, what we can deliver in the end, and what is requested by the client in terms of lead time. And this is usually called the planning index. So you have on the numerator delivery time, that is to some extent the requirement by the client, and the numerator the total lead time, that is what we are able to deliver each time. The point is that if the rate of those two terms, the planning index, is less than 1, I think that is obvious that we have to configure our production system as a make to stock, because we don't have enough time to deliver as required by the client. So it took too much time, more than the one required by the client. So the situation now, or we go in a make to stock, or we will be always systematically late. In case the planning index is bigger than 1, we can choose, okay? But maybe we can go for an assemble to order, a make to order, that are the most common ones, okay? Because we have enough time to start producing and finish producing with the delivery within the delivery time expected by the client. So if the delivery time is 1 week and to some extent the total lead time for us is 2 days only, we can decide, okay, to have only the production of components made and take 1.5 days for assembly and half a day for delivery. Perfect. Okay? So, when you consider lead times, okay, you have to take a decision about how you want to satisfy, fulfill demand for the client. Now, being back on problems, as usually some, let's say, indicators of problems, physical indicators. Delivery date, month, order date divided by the number of orders. So the idea is that how many, maybe they are expressed as a unit of measure in days, how many days per order it takes on average. Or if you want to be more precise, please remember what we said about completeness. Okay. Full completion, full delivery of the order, all the order lines completed, date of full delivery minus the order date divided by the number of orders. I think that the difference here is evident. Here we are referring not to the first delivery, but the last one. Is more challenging. Sometimes you can have both in order to keep under control promptness together with completeness. Or the number of orders filled within 5 days, 2 weeks, 1 month, okay, over the total number of orders. So you can have also a distribution in different days, which is the distribution of the promptness over your orders. Not only the average, but understanding if we have, say, a most likely value in terms of delivery time, okay, that is to some extent maybe different from the average. So maybe if you have a lot of orders that are delivered in shorter time, 3-4 days, but you have a limited number of orders with very high big time, okay, the average could be more or less in the middle. But maybe 90% of the order are delivered with good promptness. And maybe this one can, to some extent, highlight this kind of distribution. Or, if you want to be more precise, please remember that orders and lines are two different ways of zooming into the orders. We can have the number of lines filled in within 5 days over the total number of lines. Again, both of them you have to take into consideration because, to some extent, the completeness, to some extent, can affect. What about punctuality? Okay. Number of late order lines over the number of order lines. How many order lines or the row were delivered late? If you want, you can also calculate the average delay. So measure for orders, for all the orders. So if you make the average, delivery in advance orders and delivery late could compensate. So sometimes the average day is measured only for those that are late. What is the idea? If you deliver half of your orders with 5 days of delay and half in advance of 5 days, this indicator, if you calculate on the whole, is 0. You are perfect, but you are not delivering anything on time. You get the point? So usually you have always an average indicator and only for late deliveries. What are the impact? Okay, penalty if they are considered in some contract clauses. Here it could be linear with the days, linear with the value. That every number of lines you have to pay something. You have to pay a percentage of the value. Maybe penalties can grow and ramp up very quickly when the number of days increases. So if it's only 1 day, okay, just very little penalties. If it's 1 week, maybe it's 50% of the value. If it's more than 2 weeks, it goes up to 50, 75% of the value. Okay? And please remember that also punctuality can have, to some extent, also an impact on all the administrative and management, because when you're late, you will receive an email, phone call, whatever, and you have to manage all these issues. Together with, we say, the pressure that comes from a client, a critical client, important client, that asks you to speed up very quickly. Now, this is the idea that I told you before. This could be a distribution of order delivered in a particular elapsed time. So there are a number of orders that are delivered on time, and numbers of orders that are not delivered. So you will never deliver it. Why? One, because maybe your supplier bankrupt. or because something happened, or for that you will be never able to deliver those ones. Stop. One of the reasons for order not delivered is that the client, after some days of delay, changes that order. So in now making now all the previous orders. Okay, cancel the orders. There are some orders that are delivered late, but please also remember that there are some orders that can be delivered in advance. Delivery in advance could be, but could not be, an advantage. Why? The point is, what is the perspective of the client? If they are willing to have it before, okay, it could be welcome. Please remember what I say about what was the wish of the client and the agreed date, the promised date. That could be a good situation where you can welcome advance. But normally, advanced delivery are to some extent not wanted at all. Why? Because the client is going to plan how to use the warehouse, how to plan the welcome service. If you have your truck into their facilities 2 days before, you say, okay, return back because we are not able to welcome these goods. Okay? And second, as we will see later, there is a cost related of keeping goods in stock. So that if you deliver in advance, you are to some extent increasing the cost of your client about those goods. So normally speaking, advance is not good. If you want delivering in advance, means that you were able to do things in a shorter time, and this is good. But maybe you cannot send it. You have to keep it in your warehouse. Again, keeping things that are concluded in terms of fabrication in your warehouse means that you're spending money for keeping it. So the best solution ever is to do things as planned. Okay. Also, advanced production and advanced delivery could be an issue. Every time you have to check the situation, but usually is a problem. Okay? Plan flexibility, we are shifting in the quadrants of, we are always in the quadrants of service. But nonetheless, we are also entering in the quadrant of the flexibilities. What is the idea? When you plan production, and we will make it, what is the idea is that, for example, for the next week, I decide for all the days, for all the hours, what will be produced and in which sequence, which resources, people, machinery, whatever. You make a complete planning of the next week. Okay? What can happen? One of your clients can ask you, I need this product for Tuesday. So the idea is, if you consider to produce the order of your client, there are two situations. One, you are to some extent unsaturated. You have time and resources to make it, so maybe we can have some space, okay, in the planning, some room in the planning to produce that one. Normally speaking, when you plan production, you fulfill all the resources and all the people in order to reduce cost. So that this means that you have to swap or to put off some other production. Okay? So the answer could be yes, no, it depends. Okay? And here comes plan flexibility. What is what is measuring plan flexibility? The capacity of your system, of your production systems, okay, to accept this unexpected and sudden variation of the production plan. What is the idea? When you can accept or cannot accept? If you think at the production, for producing one product, you may need to have some components. You have it, or you have to issue an order to your suppliers. If you have it in the warehouse, this is available. If not already booked by other orders. If you have to ask your suppliers to produce it and send it to you, you need some time. If your supplier asks for 3 days, you will be not able at the beginning of the week to produce it by Tuesday. Internally, you have some teams working on the machines. The point is, you have to ask them to produce that particular product. Are they skilled enough for producing that one? Because maybe you make some teams and you plan their work on the basis of what they can do or not. So we have rossi, bianchi, and neri, okay, able to produce something, and other teams less skilled for others. So in the end, it means, do you have time and resources before producing and delivering that one enough for doing this or not to accept this? So the physical indicator that refers to a period in which we do not accept any variation is called the frozen period. If the frozen period is 2 days, it means that for the next 2 days, I will not accept any change order. Stop. I already planned it, and I'm not able to do this. If we look at this, at all the reasons that I told you, for example, issuing the order, make your supplier producing, you have to deliver this component that you start producing. It seems that this is just a sum of technical times. Okay? But it's true that also the technical times could be crushed, could be squeezed. You have to process these orders as they are more urgent. So you can ask your supplier, in some cases, to reduce time for delivery. So have a special truck, for example, reducing the time for delivery, not waiting for the end of the day. Or maybe, in turn, you can start producing immediately those components and send it to you. So, if you want, this frozen period is made of 2 different macro components. One is related technical time, so we cannot crush the time needed for producing. But maybe we can reduce all the time for the queue, for the priorities, for waiting, for particular, and we can, to some extent, reduce. So, the technical time, we cannot use it, intervene in that. On the, let's say, all the other idle time, I can say, we can act, but usually this requires an extra cost. Oh wait, I have to pay my supplier the double. Okay? So, if you want, the frozen period is a mix of technical issues and economical ones. So, to some extent, a frozen period is typical given, but in case the clients can spend more, you can have urgent order and maybe you can reduce a little bit this frozen period. Okay? But normally speaking, when you have the contract, your client make a contract with you about a delivery, is to some extent, if this relationship is a long-term relationship, is also defined a frozen period that is the, let's say, normal, usual one. Maybe I will not accept any variation for next 7 days, and that's all. After that, okay, you can crush the time, and they pay you the double. Maybe you can use some extra time, overtime for using for people, and maybe you can have this urgent order made by Tuesday. Okay? Mixed flexibility. What is the idea of mixed flexibility? Your company is producing a number of different products. This is called mixed production. Okay? What is the meaning that I will produce here? You see, the different products are here, and if you look at the demand, it can be broken down into a number of different items. It's, as we already know, that producing product A and then product B requires a setup of machinery, people, whatever, in the between. So, when we refer to mixed flexibility, we refer to the capacity of the production systems, okay, to adapt to changes, okay, in the mix of those products. So the idea is that those products are already industrialized ones. So we know perfectly how to do them. But product A, instead of being producing 200,000 units, is producing 600,000 units. This means that, for example, product Z that was produced in larger quantity, here is produced less. So we are shifting from one product to another. Now, how can I measure this mixed flexibility? It's apparent that the main problem is related with setup. Because if I'm changing the mix, it means that I'm changing the setup time. Singular and then the sum of setup time. So maybe in the new mix of production, I will have more time to be devoted to setup. Because I'm producing, remember, more A product and less Z product. This means that going from B to Z and B to A takes more time. Okay, so a very good indicator of physical indicator of mixed flexibility is the setup time, global setup time, or setup time related with a period of time, in a month, 2 months, whatever. Now, after that, there are some other indicators that are connected with setup time that are more easily, you can more easily measure them. What are they? Lot size of the production. When I told you that we have to produce 200,000 units of product A, it doesn't mean that I will make one lot only. Usually I will produce those 200,000 units of product A in lots of 100 pieces each. Why 100? We will be back in some weeks, okay? But we are producing it in lots. Now, if, what is the idea? If we are able to, if we want to satisfy demand from different clients, the best thing, you remember we already see, is to go with a single production. So be we can produce exactly what is needed. So the more the lots are small, the smaller the lots, the better the situation we are able to satisfy demand. Okay? If we make smaller lots, we have bigger stop time. So in the end, only some companies, some production systems can afford to have a lot of little size. That's why the lot size, smaller little size, implies a high flexibility. In the end, it's the same or say that we take a little time for setup in case we shift from one product to another. Okay, only some companies, the ones that have small setup time, can make small lots of production. The companies that have large setup time, because their machinery is not so flexible, they are making bigger lots in order not to lose too much time in setup. Okay? There is another indicators that could be interesting. So the production campaign length. What is a campaign? The idea is always related with how we can satisfy clients. Please remember that I told you we have to produce product A. After that, we produce product B. When we produce product A, we will produce enough to cover the demand during the production time of A, plus covering the periods when A is not produced. We will produce it, we put it in the warehouse, and we will serve from the warehouse. Okay? The same for B. In 1 week of production B, I will cover the period of time where B is not produced. For C, again, in that week, I will produce what is needed for the period that C is not produced. So what is the idea? With a certain cyclicity, I will be back producing product A. So I will produce product A, B, C, and then again, A, B, C, and then again, A, B, and C. In this way, I can, to some extent, have always product A, B, and C available with limited stock. Okay? We already focused on this last time. Maybe you can produce 1 week of product A, 2 weeks of product B, 1 week of product C. This depends on the demand of the different items. What is the point? Campaign length is the time required for producing all the different items. For producing 1 week of product A, 2 weeks of product B, 1 week of product C. And now we are back. So maybe 1 month. Okay? I think it is obvious that if the lot size of the single items is reduced, the campaign length reduces. So in the end, we can say that those two give the same result in the end. Okay, this is to some extent considering more items. This is considered as single items. What about the economic indicators? The cost of setup. Okay. Volume flexibility, also referred as elasticity. And if you remember, last year, we already considered volume flexibility. What is the idea of volume flexibility? Again, it's a capacity of the production system, okay? But related with the absorption of variation of the demand of the volume to be produced, okay, for a reference period, for example, for a year. So that we have a production system able to produce 1 million pieces per year, but it can go up to 1,200,000 or go down to 800,000 units. This is the flexibility, okay? Now, how this flexibility is obtained, how we can physically measure this flexibility. One of the indicators is the level of utilization of the production capacity. I told you before that we are running at 1 million. We can go up at 1,200,000 or go down, but it means that my production systems can speed up at 1,200,000 units. This means that normally, usually, I run it at an unsaturation level. I keep some of the capacity unused in order to be ready to respond to peak of demand. Okay? So, the point is, which is the utilization level? I'm here introducing utilization that in the next, sorry, I always putting it off, but we're going to exactly define utilization, but you can easily understand what I am referring to. I got 1,200,000 units per year of capacity, and over the year, I set to produce only 1 million, because I want to be sure that in case some clients will ask me to increase, I will be able to go up 20% more. It means that I'm running, okay, about 20% less, normal, 80%, okay? But it's not the only physical indicators, because maybe I can produce my volume not only by myself, but maybe I can ask subcontractors to do my job. So I can have some of the production running in my production internally and a remaining part externally. So there is some kind of competitors, to some extent, okay, that are playing with me in agreement. So the idea is that I book some of their capacity, okay. I keep on working with my capacity in case I will use their capacity. Because 1 million is my maximum capacity. I will add 200,000 units from external supplier. Okay? In this case, they are, to some extent, employed with me. They are substituting my internal capacity. I can put together the production of my production with my subcontractors one. Okay? By the way, it's quite common to have, if you think that you will have a peak of demand, to not use all your capacity and keep some of the capacity spare, okay, unused. And before using the last 20% of your internal capacity, ask a subcontractor to cover the peak of demand. And only if demand ramp up, you will use the last spare part of your internal capacity. Why? This is quite common, this way of working. When there is a peak of demand on the market, all the, if you look at your competitors, everybody will ask subcontractors to make this job, to cover the extra demand. So that if in the last day, when the peak pop up, okay, you ask a subcontractor to make an agreement, the price will be higher. The availability will be low, and the condition of the contract will be not so fair in the end. So what is the idea? I prefer to not using completely my capacity internally, but start using my subcontractor one when there is limited peak or no peak. And I will keep as a reserve my internal capacity, so that the supplier will be committed to do their job in the best way ever. Second, you will have the right price and right conditions, because it will keep on working. And when there is the peak, all this exceptional situation will be managed internally, so at the same condition as the others. Is it true that I'm having some extra capacity that maybe could be used or not used ever, all the time? So you are not perfectly efficient, but you can be, to some extent, you can deal with this kind of peaks. Okay? Now, again, I'm introducing the concept. We need some time to do this. Moreover, availability of overtime. What is the point? If you look at the man shift, in metalmechanics, it's 8 hours per day in Italy, over 5 days per week. If you go with food, it's 7.5 hours per day over 5 days per week. If you go for service like energy, is 7 hours and 45 minutes. So you have to understand which is the work contract basis, okay, for that one. In this contract, usually is defined how much overtime you can ask your operators to work. For example, okay, you can ask, for example, half an hour more. So after the 8 hours, you can ask half an hour more. Okay? This implies that your operators say, yes, I'm willing to stay here half an hour more. Second, you have to pay it more. Third, the yield, the efficiency of that half an hour after 8 hours will be lower. Nonetheless, you have half an hour for all your operators in case you obtain it. This means that you can work more and so produce more. So the availability of overtime is I would say, a lung, an additional lung in order to produce more. You cannot think to use it every day of 360 days per year, but when there is some peak, you can make some arrangement. Okay, on that. Economic. Maybe you may remember the cost volume curve. For pieces, these are pieces. Unit cost, okay, cost per unit for every piece you produce, usually have this kind of this shape, so that usually there is a point where the cost is at minimum, and this usually is referred as the volume that is used as a reference point, as a target for the production system. So this, if my production systems run at this volume, so this number of units in the year, you have the minimum cost of production. Okay, you remember this one. What is the problem? If I have to produce something more, 10% more, the unit cost of all the production will rise. The same will happen in case minus 15%, you reduce it. Okay? Why this one? Because usually the production plant is, and we will see when we're going to design it, is designed for producing exactly that quantity, and we can be to some extent a little bit flexible, okay, in case the increase of the unit cost is limited for some kind of variation in the volume. Usually a plant is referred as flexible when the change in the unit price, when we have a 10–15% is the changes in terms of cost is very limited. If you remember, this is plant 1. If you have another plant 2 that is less flexible, the shape of the curve is this one. So we have the same minimum, but with the same variation, we have a high increase of the cost. This is to some extent less flexible. Okay, we use it last year, if you remember. Okay. Now, product flexibility, the fourth flexibility. What is product flexibility? The idea is that we need to reconfigure, okay, the plant production system in order to produce a new product. This is the idea. The point is that if you need to make a new product, you have to understand how to do this design. Okay, you have to re-engineer to some extent the system in order to welcome this new product. Maybe it's similar to a previous one, more or less. So in the end, it will take time for this kind of redesign. Okay, and maybe there are some costs for re-engineering and adaptation. Maybe you have to change some fixture. You have to change to buy some tools, okay, in order to be able, you have all the machinery, but, okay, some clamps, okay, needed, that particular. So yeah, you need both time and cost. Now, not only when you start producing a new product, you're not immediately efficient doing that. Usually, there is a transient of production during which, okay, we have some extra defectiveness because we are the very first time we are producing it, and so maybe 1 out of 100, or maybe worse than this one, should be rejected. Or maybe, okay, we will have a lower so-called productivity. What is the meaning? I will use for material too much steel for producing 1 unit. A lot of rework is needed, and I have to do a lot of scraps. That in 1–2 months of production will be solved. So here you can have is a very, to some extent, complex measure, but you can, if you refer to the time for engineering and the duration of the transition together with effectiveness and lower productivity that you have in that period, this could be good physical indicators. And the cost of re-engineering and cost of this extra effectiveness and lower productivity could be a good economic indicator. Okay? Just to have a little break on that one, but just to one of a typical tough question, not too much, a typical question of the exam, just to understand if everything. Please give me 3 performance, okay, in the flexibility or service or in the quality quadrants belonging to that quadrants. Name definition, and one physical indicator. Availability, completeness, accuracy, the name, the definition, and one physical, the economic indicator, I don't know. Okay? This is a typical question that could be used in this part. I will make some examples. Okay? Okay? Now, we are entering now in the last quadrant, the ones related with productivity, the green one, if I remember correctly. And now we have to separate what is the productivity of production resources, let's say workstation, people, materials, and machines, okay? And we have to separate them from productivity of the warehouse. We start with production resources before, okay? And the idea is to have some indicators for, okay, these production resources. This is the idea. But there is another use of those indicators. So we will use as the performance that we've seen up to this point. But those productivity measures have also another utilization that is related with the estimation of the production capacity. So when we know the productivity of our production system, we have to understand how to do this, okay? We also be able to understand what was the production capacity that we had in the past, understand the causes, and try to guess, to forecast the production capacity for the next year. Okay, these are the two main objectives. Let's go with productivity. Okay, understanding the productivity of the production system means also to understand which are the different states that the production systems, could be the whole production system or the single machinery. Okay, we can refer which is the different states during the usage of this machinery. So we start with time. Okay, the time is, in this case, TS is the solar time. So we have 366 in case days per year that are available, potentially available. Okay? Usually, only a share of them, okay, can be used for producing. This is usually called the opening calendar time, T. What is the idea that usually in a production, a factory, we have 250, 260 days per year where the production system, the factory is open. Sorry, it doesn't mean that it's producing, it's open. Okay? Sometimes opening calendar time for process industry can be identical with the solar time, but usually is not. Okay? Now, of this opening calendar time, some time is lost due to some organizational causes. So everything, the plant is open, okay, but, and this is, we will back to that one in a second, but sometimes cannot, some of this time cannot be used because of strikes. We have 260 days opening calendar time, but we have 5 days of strikes. 10 days of strike. Hopefully not. It is open, but you can use it. Okay? Together with this one, now we're going to, after that, to break it down. There could be also some losses due to organizational causes. What is the idea of organizational causes? Is everything was open, there is no strikes, people was inside, but because we were not able to organize properly the production, the way we are producing, we're doing nothing. If you go with respect to a production line within your factory, it means that you have a planning of the teams working on that, and to some extent you choose the wrong team with not the right skills, or maybe there is a problem of planning with the supervisor. You have the people working, but not the supervisor. The production line cannot work. It's a typical organizational issue. Everything is there, but we cannot go. Okay? Hopefully the strikes are null. Hopefully organizational issues are null. It could happen. Okay? Now, there are also some losses due to so-called managerial causes. Lack of orders, lack of materials. Sorry, I'll jump it, but if you have the slides. Okay. Come on. Okay, are already here, so don't worry. Okay, we are here. Okay, so there are some lack due to managerial causes. What is the idea of managerial causes? Lack of order. It means that the machine, the production line, or the whole factory, if you want, doesn't work because they didn't receive a production order. You remember, you receive from the client the order, and you transform that into production order for a single machine. You didn't, as a manager, okay, provide the production order to that machine. The operator is there, machine is there, the production doesn't work. So you lose some hours for this reason. But the other reason for having a loss in terms of managerial quality is that materials are not available. Again, you can see as a production line, as a single machinery. The idea is that the production order has been received, the operator is there, machine is there, but the operator do not have materials, components, subcomponents, supply, whatever, raw materials, close to his workstation. He cannot start working. He has no input. Okay? These are called managerial because usually are related with the manager planning for that one. To some extent, they are managerial because the person that is guilt is the manager. Okay? Now, if from the opening calendar time we subtract losses due to organization and managerial causes, we obtain what is called theoretical utilization time. Okay? Theoretical utilization time that cannot be used for production completely. Why? Because we can have time for failure, breakdown, and the following time for maintenance. These are so-called technological causes. Here, the plant cannot, or the machine cannot work. Okay? A number of hours is due to the fact that something has happened or we are in preparation. Now, this is time that we can use. You see that the time for producing reduces very quickly. Is this one the right time for producing? Not yet. Because when we subtract the losses due to technological causes, we obtain the so-called actual utilization time. But we have sometimes, okay, that can be devoted to tests and trials. So that we are using the machinery or the production line, whatever, okay, for testing new production. You need to introduce a new product. You take some time of that machinery, of that people, of that labor, for testing how this new product can be produced. The line, you take all the machinery, all the people working on the line, you say, okay, in the next 2 hours, we will try to produce this new product. In the end, we're not producing, we are producing something, but is nothing that we can sell. No way. We will produce, we will analyze it, we will back, we will train them again, we will improve fixture, we will improve tools, we will improve everything, procedures, but in the end, we are doing something with machine and people, but it's time that is taken away from production. But after we subtract this time for trial and test, we obtain actual productive time. Look at this. This is theoretical utilization, actual utilization. Here we have productive. We are coming close to the time used for productive. Okay? So this time is called actual productive time. Again, during this actual productive time, are we producing something that can be sold? Not yet. Because some of this time, TS, setup time, is used for setting up machinery or production line in order to produce that particular item. And so we reduce the actual productive time to what is called machining time. This one. Okay? What is the idea? All the machining time is time for creating product that can be produced. Because we have this time where we are producing the product, but this share of product will be rejected. This is scrap production. So only this time, over that one, will be used for producing good production. Okay? If you see those that are in yellow, okay, they say they are not fully productive. So we are producing something, okay, but in the end, are not creating a production that can be sold. Okay, it's not compliant with the standard. Okay, so this kind of stairs represent all the different losses that we can have in terms of time, where we are not able to produce, something that can be sold, and try to highlight what is the time that can be used for producing. Please remember that this is the representation of time, or times, if you want, okay? But nobody is telling us at which speed I can produce. Okay? For example, they say that here we have 200 days during the year where you can produce good production. But here we are missing something related with how many units we can produce per day. If it's 10 units per day or 200 units per day, completely different, the volume we can obtain. But here it is represented, okay, all the possible state of the plant. Now, these are different representations, but in the end, okay. So solar time, the difference between the opening calendar time is that the plant is closed, open. Okay, the opening calendar time with respect to the theoretical utilization time is that we have no utilization for external causes, not related with running of machinery or workstation. Okay, the distance between the theoretical utilization with the actual utilization is given by breakdown maintenance reason. The actual productive time with respect to utilization, here we have tests and trials. And for shifting to machining time, we have to consider setup. To have the time for good production, we have to consider scrap or non-compliant production. We'll take another 10 minutes or we will stop. Okay. Now, the idea is just to recap, but also to introduce some indicators. Sorry, just to understand why we need to recap, but also to introduce some indicators. Because at the end of the year, we would like to know which was the utilization of the time and how much time I spent in the different states, with the idea of reducing all the time lost. Okay? We have different way of acting on each of them, but it is apparent that if I can increase this time up to the opening calendar time, I will be perfect. Okay? More or less. And so, what I can measure, we will see this one. I can measure, I would say, the percentage of the different steps I got here with respect to the others. So, for example, I would like to know how much of the opening calendar time I can go with the actual utilization time. Only the 60%, 65, okay? I'm measuring, I can compare with the previous years. I can say it's good, it's bad, it's better, it's worse, why? And I can say exactly how the things went. But I can also use this 65% to understand in the future which will be the actual utilization time. Why? Because if I enter the opening calendar time on the next year and I multiply that by 65%, I can expect to have, for the next year, an actual utilization time of 60% of the new opening calendar time. Okay? This is the idea of reusing, of assessing the past, understand, forecast. After that, you don't like the result because it's too low. I can say, I would like to reduce the time for maintenance, for failure. I can have an intervention that will lead us to a reduction on the repairing time. I can update the 65% that will become 70. I will use it for forecasting the future. Okay? And this is the way we're going to use for forecasting future capacity of the system. Okay. Again, this is take a look, please, on measurement. Time, this is time measurement. In the next slide, time measurement will be with a star, and at the end, it will become quantity measurement. Okay? Okay. Solar time, opening calendar time, theoretical utilization. Here we got plan close and no utilization issues because of strikes, because of organizational issues, because of lost lack of material, lack of orders. Okay. All these times management are always measured in hours, days. Strikes, usually measuring days or hours, strikes. Time that you lose, idle time, that you lose because you don't have material. I waited 3 hours before the components come into my workstation. Okay? So, these are always times. In the next step will be not like that. You got downtime given by both failure and time for repairing. And here we will find what we perfectly know that is called availability. Availability that is given, if you remember, uptime over the sum of uptime and downtime. Number of hours that you spend working over the total time. Here we can refine what we used last year and say that availability is better to be calculated as actual utilization time over theoretical utilization time. What is the idea? Availability reduces theoretical utilization time and give you, as a result, the actual utilization time. If I'm back here, it means that all the lack of order, lack of materials are not included, have been subtracted before. Okay, subtracted. And now this one is no more a subtraction to some extent, but is a multiplicative indicator. If you multiply availability by the theoretical utilization time, you obtain actual utilization time. Okay, here we have the problem that we are going to have it. We have to subtract a time, or we have to multiply by a percentage that reduces in the same way. So is the loss proportional, or is just a fixed time to be subtracted? Strikes. We have 5 days of strikes last year. That was, I don't know, 1% of the time. When we project in the future, we're going to understand there will be a number of days of strikes, or will be 1% of strikes. It's upon that the strike will be always related with a time, a number of days, not with a percentage. Okay? If we look at failures, time for failures, it depends on the kind of machinery, but if we go for less automated machinery, the more we work, the higher number of failures we have. No way. It's proportional. In that case, the multiplication is absolutely the right way of using these indicators. Okay? This is true when we got maintenance that is by event. The more I produce, the more I will have failures, the more I will need to repair. But if I go with preventive maintenance, so I decide that we are close to the moment when it's going to, we have high probability of breakdown, and I will take 2 days for substituting the belt, substituting the gear, I don't know, whatever. In that case, this is a fixed time, and it is not proportional to the production. So there are causes, losses, that are proportional to the production, and causes that are to some extent fixed. And then after that, there are losses that are to some extent fixed and proportional. If you look at the losses for technical reasons, failure plus maintenance, is it true that more I work, more I need to make intervention? Even if I plan it in a preventive way, I will add more intervention. So in the end, it is both proportional and not proportional. Okay? This is something that we will find more and more time. Okay. In this case, availability is an indicator that is transforming the theoretical utilization time into actual utilization time. Now, different companies, different way of doing things. I am preventing what will be, I would say, the right one, but there are some production systems that prefer not to have the time for trial and testing in this calculation of the availability. Because they say, why I should consider the time spent for trial and testing in the indicators that is representing how many times my machine is broken down. In the end, it's not related with production, but with testing time. So somebody say that the time for test and trial should not be included. Usually the time for test and trial is limited, so the difference is very little thing. But it could happen. I prefer to have it, because in the end I'm using. It's true that the use of machinery during test and trial is, I say, more heavy duty, because in the end, but you are also more accurate in the using, because you have to understand what is going on. So I think that they are, to some extent, cancel out the effect. In case you will work in a company that make a lot of one-of-a-kind products, it's true that the time for test and trial could be bigger, because every time you have to test and trial to start the new production. And if you go on one-of-a-kind, it's a point that every time you have the new product, you have this time. Okay? But this is a particular case. So I will take some minutes and more. Okay? And this is the reason why here I put the star. Because if in the previous losses, those ones were substantially related with fixed time, when we speak about the failures and maintenance, it depends on which kind of maintenance we're taking. If it's preventive, by events, predictive. Okay? If we are preventive and predictive, these are time measurement. If we go by events, they are instead multiplication by quantity. Okay? Said that digitalization is pushing more and more with time measurement. If we go back only 10, 20 years ago, everything was measured in terms of quantity, not in time. Nowadays, all the new Industry 4.0 machines have all the time spent so we have all the time. Okay, even if I'm selling units, not time. Okay. Now here we got all the so-called non-productive plan, productive time. So we transform utilization into production time. And this is the new indicator. New indicator is utilization. We will use it a lot, the same as availability. It transforms the opening calendar time into actual production time. Just to understand. Okay, this is actual production time. It transforms this one into this one. So all these losses in utilization are embedded. And availability itself is one of the components of utilization. Because if you remember, availability is transforming theoretical utilization time into actual utilization time. This step. Utilization is shifting from this one to this one directly. Okay? Now, why not everybody use utilization? Because if you look at the production system as a bare machine, okay, you remember what it says, the perspective, you're only a mechanical engineering. You see only a single machine. Is it true that you don't think at all the managerial issues? Because the machine have always material and always orders. None strikes, I don't consider them. Okay. Failures and maintenance is free because the machine is broken down, so that you reduce utilization only to availability. Okay, I will be back to that one. But utilization is the main indicator, and availability is one of them. Only in particular cases you can use availability as an approximation of utilization when all this and all this causes are not. Okay, otherwise you have to consider the other causes. Actual production time, machining time. Here we got setup time. Okay, to be more precise, in the end there is a setup time of the machine, but also we have a contribution, minor contribution if you want, of minor stop. Like topping of topping up of liquids, or machine integral oil, or cutting oil, something like that. You need to make something, or sharpening of the tools, okay, is not a setup due to the change of the products to be produced, the changeover, but is some setting of the machine to have it in the perfect condition. Okay? And now we come to the last part. Quantity measurement. Up to this point, we refer to the time of good production, time of scrap production, time for setup, time. But I think that all of you understand that when you're close to having the goods in the warehouse or delivering the product to the clients, you're speaking about units. Time is transformed into units, and units are measured, as I told you before. So here we got machine time that can be transformed into time for compliant or good production when we subtract, okay, the time for non-compliant production. Easy, okay? easy because it's time, but in the end, we have to say that machining time usually is referred as number of units produced, the quantity produced. Produced doesn't mean that it's good or not, produced. After that, we got a percentage that are scrap unit and another percentage that is saleable unit. Shifting from time to quantity. Okay, this is the point. And here we got some indicators. Okay, following the previous one, we have the so-called quality yield that is given by the number of good compliant unit over the total unit produced. This one over this one in the end. Okay? I must say that usually it is using the so-called effectiveness rate. That is the number of non-compliant units over the produced unit. Okay. 1 minus quality yield gives the opposite. Okay. So 90% of the production is good, or 10% is crap. Okay, it's the same. But here we have another interesting indicators that is called saturation. Okay. Saturation, we will find many indicators that are referred as saturation. Okay. This is saturation referring to machining time. And is given by the machining time, this one, over actual production time. This one over this one. So take in consideration setup. The higher the saturation, the lower the setup time. Very simple. Please remember that setup time is a no value added activity. If we reduce it, okay, this will not give any additional work to the production. Okay, that's why we keep an eye on that. So saturation should be high enough. After that, we know that we need setup time, but if we can reduce it, the client will never understand that we use it. Okay. And here we can stop. I think we can back in a quarter. So some minutes before 10 past 4. If you have any question, please ask me now, have whatever. Devo trovare come fare, non so perché esercitare la carica elettrostatica, ma non funziona il scusi, vengo subito che sblocco soltanto la registrazione. Non so come fare a bloccare la registrazione. Un secondo, non è mai successo. No, ci siamo anche prova a fare qualcosa, no? Idea sono ben accette, Brutta persona. Prima ho provato a fare col trackpad, no?
Allora. No, non lo prende lo stesso. Come se fosse dal lato del...
Sono uscito, non so per quale ragione. Okay, so up to this point, okay, we are able to represent how the time is used and how much time the plant, the machinery, okay, spent in all the states, okay, that are represented by, or say, by these stairs of the times, starting from the solar time up to the time for compliant production. It's apparent that all the losses should be reduced. Doing that, we will have more time for producing. This is the idea. Okay? Now, what is the next step we have to take? What I told you before, we have to transform time into a unit of production and vice versa. So the point is that we don't need only a representation of how the time is utilized, but also if at which speed we can produce during that time. So we need another indicators of the speed at which my plant is producing. How many units per minute is going to produce? Okay, it's apparent that if I can increase the time for good production, and if I can increase the speed, I can produce more. Okay, this is the idea. Now, what is the idea with the number of units that we can produce? We already introduced before the so-called standard time. Remember, we use it when we look at the impact of measuring on, for example, in terms of motivation and expectation. Okay, so that when we have to set how many units we can produce, we have to time an operator working and understand how many minutes it will be necessary to assemble a product. So, and we test it, and remember the two different behavior: the eager behavior, quicker, or the disputeful behavior, the one that takes more time because this standard time will be used as a target for the production. Do you remember? So, what is the idea? Now we have to understand how we can compare what is the standard with what is the actual. So, this could be in terms of actual status, okay, and okay, the standard status. In particular, if you want, okay, the idea is, for example, compare to some extent the actual production rate with the standard production rate. So, number of products that are produced in an hour compared to the number of products that are expected to be produced in an hour. So we can understand what has happened in the last year. We expect to produce 10 pieces per hour, and we measure that we produce only 9 pieces per hour. This is a difference in the, or the opposite. Maybe we expect to produce 10 pieces, we produce 11 pieces better. Okay? And this is what we need to do in terms of comparison between the standard and the actual. We will refer to this one with the terms of efficiency. We will find it later. Okay? How much we are efficient with respect to the standard. before being able to use this concept, we have to introduce all the so-called productivity measure. You remember, productivity measure is understanding how workforce, plant or machines, and material are used. All the productivity measure are the rate between a volume, production volume, and the level of use of a certain production factor. This is true for material, machines, and workforce. Typical is understanding how many units for hours of machines, how many units for direct hour of labor, how many units we can produce with 1 ton of steel. Typical. It could be also for energy. So one engine requires a number of kilowatt hours. Okay, one engine requires 1.1 4-cylinder integral oils of a kilogram of integral oils. Okay, this is the idea. Now we can express productivity at different level of zoom in for a single machine, for a group of machines, for the entire production system. As the availability, if you remember. Okay, we will be back understand which is the best zoom to be used as the Hamlet question that I will pose at the end of this lesson. Okay, understand which are the difference. You remember also that measuring the same indicator, the same performance at different levels, okay, will change the consideration we can make it. It is not true that two machines that have a higher efficiency have an efficiency of the factory as a whole, because it depends how they are connected. Now, if we look at all the different kind of measure of productivity that we can use, there are so-called partial measure. That is, we have the output on a single input. You get this one. Okay. So it means that the output number of units over energy, the output on machine hours, output on hours of labor, as I said before. Some other times, but I don't like it very much, but you will find, if you keep working at a factory, you can have so-called multi-factor measure. So it means that you have the output over a number of inputs. So for example, the number of units over kilowatt hours plus the cost of the machine. I don't love this kind of, because we are summing two factors that have different units of measure. Okay, but this is quite typical of process that have two factors that are by far the most used. So that summing the kilowatt hours and the number of hours, you find some kind of indicators. I don't like it. I just tell you, but you will never find me using such a measure. In case you need to have more factor, multi-factor, or total inputs used, it's by far interesting to use monetary terms. So the only way to put together energy, labor, machines, materials, whatever, in the end, you express all of them in monetary terms, and you have an idea also of the cost of the resources. From my point of view, is the only good way to put them together. Otherwise, use the partial measures. Okay. Let's go straight to the point. Now we have to understand. Here it's referred to diagnosis. Okay. To understand what is going on, productivity as the number of units over the input could be interesting in terms of performance, but if you have to understand what's going on, it's better to break down productivity into two subfactors. Those two subfactors, okay, are utilization, okay, we already introduced this one, and efficiency, we try to introduce as well. What is the idea? Utilization multiplied by efficiency will give us productivity. And now we will understand why and how. Okay? Utilization has been already used, efficiency has been something hinted. Just okay. Now, machine utilization. Look at the stairs. Remember the time stairs. Utilization we already defined, okay, as the actual production time. This one. Over opening calendar time. You remember utilization taking into consideration a number of different losses. Okay? And the idea is that the numerator is opening calendar time, no way. The numerator can be calculated into different ways. One, going down the stairs or going up the stairs. So you can start from the opening calendar time, you subtract the lack of orders, lack of material, strikes, organizational causes, the failures, maintenance, and the test and trial time. And you obtain the actual production time. On the opposite, you can start here, you sum the time for good production, you add the time for scrap production, you add the time for setup, and you obtain the actual production time. Different formula, same result, no way. Okay? As usual, both of them can be available. Most of the companies have those numbers here in terms of times. Do not have those ones. Why? Because usually those ones are measuring unit. Remember? While those ones are usually measuring hours, only some companies, but the ones that I think you're going to work with, will have in next future timing of good production, timing of scrap production. But we can manage in the situation, don't worry. Workforce utilization. Workforce utilization, again, is given by actual production time over paid hours. Okay, why? Please remember that all the hours that labor spent in the factory is registered and paid. This is by law. So this is, I would say, data that is always available and is sure. Okay, and to some extent have to deal with, with the number of hours that we can use during the opening calendar time. As before, formula doesn't change. Okay. The other things that we can add about utilization, both machines and workforce, is that utilization is always less than 1, not equal or less than 1. Because utilization transforms opening calendar time into production time. So it's a percentage, 0.8, 0.6, 60%, 70%. Okay, maximum, theoretical maximum is 100%. So all the opening calendar time is to some extent the production time. Okay, no way. Efficiency. Okay. What is the idea of efficiency? Compare the time used actually, okay, with the time that could have been expected for producing that quantity of products. Okay, so look at how this is actual production. So you go at the end in the warehouse, I say, and you count the number of units that you produce of one product of n different products. I don't care, okay? And you transform them with the standard production rate. So product A required 8 hours to be produced. So if I found one product A, I know that 8 hours, it was expected. What is the meaning of expected? Because you remember, we set a standard time for producing product A. We measure in order to have an idea which is the standard. So if we find product A, this is 8 hours, for example, for pieces. Product B is 4, product C is 2. So we can understand how many hours, standard hours, are stocked in the warehouse. You see product A, product B, product C, but you can transform them into standard hours needed to produce those products. The hours that were expected. The numerator, we put the number of hours that were used to produce them. It is apparent that if the actual production time is bigger than expected one, we were, let's say, less efficient. The number is less than 1. But the actual production time is lower than expected one. It means that we took less time to produce it. So we are more efficient than expected. Okay? If we set the standard time in a fair way, it can give us a good way of analyzing what has happened. Okay? If we failed in setting a fair standard time, it's a mess. Remember the truthful behavior. We have a number of trials. We set the standard times with those labor that slow down or takes the double of the time for producing, and we set the standard time as the double. When we, at the end of the year, we measure actual production time, maybe we think that we are Superman, because in the end we obtain wonderful results. But in the end, it's not. And the comparison with competitors will reveal the situation. Okay. On the opposite, if we found some eager behavior, I want to show, those people want to show that they are good at doing their job. At the end of the year, I will find that actual time is by far longer than expected one. And efficiency is very low. But in the end, I was not so bad. Okay, so now we make all the measurement, we test, retest it again, and we assume that the standard time were set in the right way. So if the actual production time is bigger than standard hours required for doing that production, low efficiency. If actual production time lower, high efficiency. And so efficiency can be higher or lower than 1. Okay? So please remember what I told you. On the numerator, okay, we have a time, and the numerator we have a time. This time is the number of hours expected to have the actual production in place, and the numerator, the time actual production time. Okay, what we measure. So please remember what is a numerator. Numerator means that we know the number of units that has been produced really. We use the standard time to transform them into hours. But using the standard time, we obtain the standard hours that are stocked in the warehouse. Numerator is what we measure as number of hours used. Okay? If you want, this can be expressed as the sum of the standard hours used for good production of product 1 plus scrap production for product 1 plus the standard time for setup. And this is for product 1, product 2, all the products. Denominator is the sum of the good production time, scrap production plus setup time for all the production. Okay? That. And to some extent, here is the idea. As I told you before, productivities can be seen as utilization multiplied by efficiency. This is the measure. So, if you want, the productivity is the sum of two concepts. One, how I was good to utilize time without losses, and how fast I went during those times. Okay? If we go with workforce, productivity is produced volumes on paid hours, as we said before. But we can also see utilization multiplied by efficiency. I think it's apparent that the numerator of utilization is the same of the numerator of efficiency, and when we multiply them, we have volume standard hours or paid hours. That is exactly the utilization. Okay. For machinery, produce volume on, in this case, installed capacity in terms of opening hours. Opening hours, volume in standard hours, actual production hours is what this can be. A little bit different is with materials. With materials, I will say that splitting, okay, productivity into utilization and efficiency have a, I will say, a lower meaning. If you want, okay, what is the idea here is that here we have in the efficiency how we were good at using materials in terms of scrap. What is the idea? When we have, for example, a metal sheet, and we have to cut it in order to obtain some components on this metal sheet for a cutting tool, the remaining of the metal sheet is to some extent a scrap. Okay? How good I am in designing the different shapes is a matter of efficiency. Or typically, if you got coil, we have to cut it with the right dimension. Maybe if you have a very big, I would say 125 centimeters of width of the band, I have to cut it in a smaller of 20, and we have 5 centimeters left. This is scrap. Okay? On the opposite, okay, we are producing from the metal sheet, cutting 100, 200 pieces, okay, but only 180 of them are good. The remaining 20 are rejected. So these are the two ideas. One is related with rejected. The other is related with the efficiency in which I'm using material for obtaining those products. One is for production, okay, and the second is related with how many of these components are compliant. Okay, if you want so scrap against again together with rejected. Nonetheless, when we speak about materials, I would say that productivity maybe is the most adopted measure, so only this one to some extent. Okay? But you can split it down. More interesting with workforce and machine. Now, let's make some examples. Here we got utilization. We got an opening calendar time of 750 hours. We have an actual time of good production for product 1 of 260 hours. So in this case, they were able to measure actual times. Time for good production, actual times for product 2 is 407. Again, time for scrap production for product 1, actual 8 hours. So you see here that the total machine time was 268, 8 scrap, 260 good. The same for product 2, 407 good, 3 scrap. Okay? We got time for failure, stop. We have a loss of 12 hours. We have a loss of 9 hours for repairing. We have spent 7 hours for test and trial. We have a time for setup of 21 hours. We have a loss related with lack of material, not material close to the machinery, of 4 hours, lack of order of 14 hours, organizational issues for 5 hours, no strikes. Okay? This is the description. The point is how we can calculate the utilization of this machine. We remember this one or this one. If we use the first one, so from the top, and we go down to actual utilization, with the productivity time, we have T, the opening calendar time, it was 750. We subtract lack of order, we subtract the hours of lack of material, strike is 0. Organizational time is 5, failure is 12, repairing 9, test and trial 7. And we divide by T. So again, actual production time over opening calendar time. So this is 93%. So 93% is the utilization of this machine. Okay? Can transform the opening calendar time into actual production time. Okay? On the opposite, if we start from below, we have 260 hours for product 1, good production, 407 hours for production, good production of product 2, 8 and 3 hours scrap production for product 1 and product 2, and 21 for setup. Dividing by, this is again time, the actual production time, okay, divided by the opening calendar time, and the utilization is 93%. No differences. Okay? So now, these are the results that we have last year. Okay? We know maybe we can act on some of these losses. Okay? We think that we cannot, we don't have budget for acting on that. We can expect that the same losses will happen in the future. Okay? So immediately, this is the past, this is the future. I have to make the budget in terms of production for the next year. I know the opening calendar time of next year, because this is made available in the last month of the previous year. I multiply them by 93%, and I can tell how many hours of actual production time I have for the next year. Okay? With a little modification. Which one? Okay, I can act on all of them. In this case, I say I have no idea of that thing, but lack of order and lack of materials, I am the manager. Can I project my mistakes in the future? It's not wise. You get my point? It is my fault because I didn't plan in the right way the materials close to the machine and the production orders. So here we lost 14 hours and 4 hours. It was my fault. I am planning the future. I cannot plan my mistakes again. So usually when I project utilization, I will take this formula, but I will put 14 and 4 at 0. Okay? Understandable. So, to some extent, if I have lack of order, lack of material, usually the projection will be a little bit higher. I don't know exactly which is the impact, but it will rise a lot. Okay? So I will, I know, 97% in the future. Because I cannot say I will make the same mistake. Okay? Efficiency. Again, we need the data. Here we got, for example, pieces. Production. The production, goods production, sorry. For product 1, 200,000 pieces. Production, good production for product 2, 240,000 pieces. Scrap production for product 1, 4,800 pieces. Scrap production for product 3, 1,200 pieces. Okay? We know which is the standard production rate. So we can produce, 800 pieces per hour. Okay? For product 1, and we can produce 600 pieces per hour for product 2. We already measure with time the time required for producing good production, those 200 pieces, for the scrap production, for the good production of product 2. See, the same data that we have, the same case. The actual time for producing scrap, the actual time for setup, and the standard time for setup. Efficiency is a matter of comparing standard with actual situation. Remember, no? We have to put it together. Sorry, just to standard production time is 18 pieces per hour, but we can have also the standard production time, that is number of hours per piece, is enough to make a reciprocal. Very easy, but okay. Efficiency. We describe efficiency as the actual production in terms of unit that we produce that we can transform into standard hours by multiply by the standard production time. And we divide by the actual production time. So, in case we have the number of units, as we have, good production, scrap production, we divide by the standard production rate, we transform them in standard production hour, plus the standard production hour for setup. And we divide by the actual times. So if you remember, numerator now is given by number of units, good production, 200,000, plus scrap production, product 1. And we divided by 800 pieces per hour. So this is hours in the end. Pieces multiplied by hours per pieces divided by pieces per hour is hour. Product 2, 200,000, 40,000, sorry, unit plus 1,200 pieces, again divided by the standard rate, plus the standard setup. We divided by the number of hours required for good production, scrap production, product 1, good production and scrap production for product 2, and actual standard time, setup time. We divided this one by this one, and the efficiency is 97%. Close to the standard, a little bit lower. We were not as fast as, but we were close. Okay? Again, we try to change a little bit, but sorry, it's the same. In this case, we have time for good production of 1, time for good production of product 2, time for scrap production of product 1, time for scrap production of product 2, the standard time and the actual time for setup, and the time actually taken for good and scrap production of product 1 and 2. Is another kind of data, but are identical. Okay. In this case, efficiency always the same. It will be given by numerator standard hours divided by actual hours, as before. In this case, the denominator is identical as in the previous exercise, but the numerator has directly the numbers of the quantity of hours. Again, efficiency is the same, 97%. Okay? Now, I go back. Okay, to these stairs. Okay, this is to some extent, the most, from my point of view, the most representative way of the different states of a plant, machinery, and also workforce. Nonetheless, okay, another framework for analyzing the state of the plant has been proposed. Okay, and this is called OEE, overall equipment effectiveness. It is to some extent more recent, even if have a number of years already, and has been created for more automated machine or more automated production line. Okay, is based on multiple indicators. Okay, I will tell you later why. Okay, but it can work very fine, good way in case you have automated or production lines that are again automated systems. It was so simple that a lot of companies thought the past that can adopt it in every kind of production system. So nowadays, many companies use this one. So what is my idea? I present this one, to make also exercise with this one, but I want you to start thinking about the differences among different models. Because sometimes it makes the difference. So it can give you different results. Okay? So you have to test, the assumption of using this one. Usually company don't test assumption. Don't verify assumption. We'll see. Okay? What is that? Nonetheless, being this maybe most adopted, one of the most adopted one could be useful. What is the idea of OEE? Is that is another framework of time aggregation, similar to Johansson, is that they want to distinguish between planned and unplanned cruises. What is the idea is that all the things that I can plan, I want to use it I want to highlight. All the unplanned, I want to put it in another indicator. This is the idea. Okay? As I told you, checks assumption about time. Careful, I will show you. So they use similar terms, but a little bit different. They say that the planned production time is different from previous. And they say that this is opening calendar time without strikes, without lack of order only, without maintenance, without tests and trials. They pick up different causes. What is the idea? If you are in an automated production system, it's true that all those times, okay, are to some extent planned. So you can subtract them. Let's make the example of maintenance. Maintenance is planned. I told you before, if you are in a more automated, more process industry, usually maintenance plan is preventive. So you know perfectly that you will lose 2 weeks in August for maintenance stop. Okay? So you can subtract from the time available for production. Lack of order, there is no failure. Because failure is not planned. You will find it. You get the difference? Lack of material, lack of orders. Okay? Lack of orders, so planning the work orders is to some extent, in a more automated way, is a matter of the manager, but not the material that should be available. I say that is a hard assumption, but it is typical of automatized strikes and not organizational. You may remember external causes. There is strikes. Strikes, I cannot work. Organizational, I don't have organizational issue. Why? Because it is an automated line, so it's true that the organizational issue will impact less. You get the difference? The way of thinking. And tests and trials. If it's a production line, automated production line, tests and trials are planned 1 year before. We will see later that the production line usually produces a limited number of sets of products, and when you have to set it, you have to reconfigure the line. So this is here. This is good for automated production lines, but for all the others, doesn't work. So I would say that if you adopt this one without reasoning, a number of issues will appear. Okay? Nonetheless, I see that company use it. Okay. After that, operating time, it is given by, I would say, the planned production time minus failure, tap, and lack of material. Okay? They define net operating time as the sum of standard time for good production and scrap production only, and fully production time as the sum of the times required for good production in standard hours. Okay? OE is calculated as the product of 3 contributing factors: availability in the perspective of OE, performance in the perspective of OE, and quality with respect to OE. They look like the ones that we've seen before, but they are different, a little bit different. Okay? Availability, okay, considers the impact of downtime, only breakdowns, not maintenance. Remember, we already taken it out before. So, and the availability is operating time less plan operating time divided by performance. Take account the speed loss. So is the ideal cycle time, standard idle time, divided by the actual operating time, that is given by operating time divided by the number of pieces produced. This one could be similar to utilization, availability. This one seems performance to be similar to efficiency to some extent. And quality, take into account quality losses, is good pieces on produced pieces, but not in quantity, but with standard times. So it works only with times. Usually automated lines are able to measure and time the quantity of time used. So in this case, availability is given by operating time over planned production time. And these are the formula that we've seen before. Okay. Please note that this availability OEE is close to the concept of utilization. Try to compare them. Okay. Because some difference appears, the ones that I told you before. Please remember that when I introduced utilization, I told you that for automated lines, availability is very close to utilization in the other framework. Here, they are saying that their availability without maintenance is availability. Okay, so maintenance makes the difference here. Okay. You get the difference we said before. In the previous, availability taking into consideration failures and maintenance. If you look at this one, only failures make the difference. Okay? So is close, not the same. Again, performance. Standard time over operating time. Close to the concept of efficiency, not the same. Some differences. Among the other, standard setup time. With it. You get my point? Again, in an automated line with a production line, usually we have we will see later, one product only, or two or three very similar products. So setup time for this kind of production system is not an issue. So setup time is not impacting so much. But if you are not in that standard, that assumption, in a job shop, in an assembly line, whatever, this will give you a wrong result. So please check carefully assumption. Because many of your managers will ask you for OEE, but you have to understand what you are doing. In case you are in an automated production line, check but go. In the other case, I think that will give you not good results. Okay, not sound results. Quality. Not bad, very similar to quality yield or 1 minus the effectiveness rate. But please remember that here we're speaking about time and not quantity. Okay, this is the main difference. Okay, so OEE more and more adopted without verifying assumption. OEE has been created for particular production systems, and from my point of view, cannot be adopted without re-verifying all the assumptions. Otherwise, it's not used. Okay? Okay, and now OE is the multiplication of the three. So in the end, it's full productive time on planned production time. Now, production, remember that we have developed a number of productivity measures, sub-productivity, utilization, OE, availability, quality, the effectiveness rate, whatever. But the use of all these productivity measures can be adopted also for understanding, which is the production capacity. So the number of units that we can produce over a year. So now we're going to tackle this issue. And we start from production capability. It is not capacity yet. Okay? There are different ways of defining production capability of a production system. In particular, production capability refers to some both technical and physical limitation, okay, of this production plant. And there are, I would say, several different ways, but three are the most adopted and well-known about capabilities of a plant. One, related with physical product limitation. So the capability of a lathe is, for example, the distance end-to-end. So you cannot accommodate a piece that is longer than 2 meters. You don't have the space. Or maybe the weight, or there are some physical characteristics. Okay? So there is a limitation in terms of physical product. Very easy. Okay. In terms of later, you have end-to-end product of 20 meters, but there are special machines. More capability in terms of technological processing. What is the idea? Is the available set of production process that a plant can, to some extent, use. Milling, drilling, for example. Okay, and this is another way of capability. Capability in terms of different processes that can be implemented. The third capability we are interested in refers to the so-called production capacity. So the production quantity, okay, that can we produce in a given time, typically in a year, okay, and is also referred as productive capacity, plant capacity, also throughput, okay. These are different terms, and we will focus on this one. Now, the idea is that this production capacity, okay, is defined as usually as the maximum, okay, quantity production that we can produce in a year, okay, but under the assumption about a number of different factors. Among the others, but there are some operative conditions like shift per month or per day. If the same production plant works on 1-man shift or 2-man shift or 3-man shift per day, it changes completely. Okay? Otherwise, on direct labor, manning levels, or 280 left, 180, whatever, or the number of hours per shift. If we use entirely the 8 hours in metalworking, or we overlap them in order to have a pause, a break. Okay, so it's only 7.5. Okay, so this is the idea. How we can measure production capacity? Okay, usually in terms of output units. Tons of steels, number of engines, whatever that we can use. This is true, but okay, the outputs should be homogeneous. Engines, outputs. What if they are not? So my factories produce different products that are, to some extent, very different in terms of resource use and time. We will see later that we can transform the different quantities into hours needed and sum them up. Or equivalently, we can express the process capacity, my production system produces product A and product B, all in unit equivalent to product A or product B. Okay? We will make it in a second, but we need some time. Okay, even if production capacity is a flow unit per year, often is referred as a production volume, okay, units, but is implying that we use year as factor, okay? So volume means production capacity, is a flow in the end. Now, what is the idea here? If we have a monoproduction, the fix is quite easy because we have a production rate for one product. We can multiply it for the number of hours available for good production, and we will obtain the volume. Simple. Okay? It's a little bit more complicated when we have a multi-product. So here we have to speak about not production rate, but a P-mix, so a mixed production rate. So to understand, because we have different products over the year, and we have to express them with a single number. Okay? And the idea of this production rate is to express this production rate as the number of the different products, okay, over the time they have been used, considering the setup time, because it's time used for the mix, for the changeover from one product to the other. Okay, so that P-mix will be always quantity produced, quantities, if you want, produced over time required, but with this consideration about setup. If we want to define production mix, to some extent is quite easy. For all the products, we have the number of good pieces plus the number of scrap pieces. Easy. Over the time required for producing good pieces and scrap pieces plus setup time. Very simple. Okay? What is the problem? It's really that this P-mix make reference with a specific production mix. If the production mix will change, mix flexibility, remember, we also have a change in the quantity of setup and the time of setup. So we can affect this one. Okay? This is the problem. But we can calculate in this way. Now, here, what is the idea here is to try to express production mix production rate, sorry, in terms of standard time as usual. So what is the idea? Here we got the number of units produced, both compliant and scrap, and divided by the standard time required. Simple. We took the number of units produced, both scrap and good, and we divided by the standard production rate. And we transform in standard hours. Okay? Or the opposite, if you want, we can transform the time, the actual time used for producing product I, and the time for producing scrap product I, and we multiply for the standard hour and divide it by the actual time. Okay? In the end, it is equivalent. It is always referred with mixed production rate in standard hour. Now, a good way of expressing the mixed production rate is with reference item equivalent unit. So we produce product 1, 2, 3, and 4. And the idea is transform product 1 into unit of product 1. Unit of product 2 into unit of product 1. Product 2 into unit of product 1. So all the different products into unit of product 1. Okay? What is the idea underpinning is that we transform the unit of product 2 into hours, and then in number of units of product 1 by dividing by the standard production rate. Very simple. Okay? This is a way of trying to have an indicators of the capacity of the system, at least in terms of one product. Why we should have in terms of one product? Usually this product is the most important one, the historical one, so that all the operators, all the managers have a more feeling of what you're saying. Okay, you have one product that have a good share, historical good share of the production, and some others that are similar with different modifications, so that you can express them in the to the product that you are more used to produce, and you can better understand what's going on. This is the idea. Okay? Just to make an example on this. Okay, we have to calculate mixed production rate in mixed equivalent unit and in product 1 equivalent unit. So we can use both. Said that, I recommend you to use more the product equivalent, the reference product equivalent. Here we got a usual number of pieces of 1, 2, both good and scrap. Standard rate, standard production rate of 1 and 2. The time for good production, bad production for the 1 and 2, and the setup time. Very easy. Okay, the formula that we see before. Here we put the number of good production of product 1 and product 2. Scrap production of product 1 and scrap production of product 2. And we divided by the number of hours required for production of product 1, both good and scrap, dividing the number of units good and scrap by the standard production rate. So here, this rate is exactly the number of hours required for producing product 1, scrap or good. The same for product 2 plus the standard time for setup. As we calculate this time by dividing with standard production rate, those are standard production hours. Okay? And we obtain production mix of 1675 pieces per hour. If you want, equivalently, we can have, if you remember the two formulas, standard production rate multiplied by the time divided by times. Again, we got number of units, the number of hours, good and scrap, multiplied by standard production rate of product 1. These are pieces. Number of hours for producing product 2, good and scrap, multiplied by standard production rate. These are pieces of 2, divided by number of hours. Same result. Okay? Depends on which are the starting data. If we want to have the production mix expressed in unit 1, product 1 equivalent units, I think that it is very simple, as we said before. On the numerator, we have to have unit. Denominator, we have to have times. If they have to be expressed in terms of product 1, we already have number of good unit and scrap unit of product 1. And they are there. But we have to transform the 240,000 units of good product 2 and 1,200 of scrap production of product 2 into P1 equivalent. What is the idea? We multiply for the standard production rate of 1 and we divide by the standard production rate of 2. We transform the product 2 into hours and then back in product 1. Okay? So now, on the numerator, we have all unit of product 1. Real 1 and equivalent 1. Denominator, we got number of units of 1, number of units of 2, divided by the standard production rate of 1 and 2. Again, we got standard production rate, standard production hour. Number of pieces per hour is 776 pieces per hour. Okay? On the opposite, if we have, instead of the unit, we have the hours. Remember, we can have hours or pieces, depends on which kind of system we have. We are measuring pieces, we use this one. We have hours, we can use this one. Number of hours, we transform that in units. Number of hours, double transformation to have in before in hours of P1 equivalent, and then back to number of products, units, 1. Okay, we have some time. Okay, and we divide by the number of hours, same result. Okay, so what is the idea? Same. Okay, sorry. We are producing only one product, no issues. We have standard production rate of product 1, and we can go straight, no problem. If we have 2 products, we have to put them together, okay, with setup needed for shifting. So what is the idea? We take one of the 2 products as the reference one, product 1. Why? Because this is the, maybe have the largest share, is well known, is the most historical one, whatever. But we transform the unit of product 2 into equivalent unit of product 1, and we can sum them up. Okay? That's all. Now we can also calculate the actual one. Please remember the ones that we calculate up to this point were PMIX standard. But we can also calculate the PMIX actual. Here all the numbers are actual. Okay. You remember those numbers that we've seen before. The formula is always the same. Number of units actually obtained over number of hours actually used. In this case, the actual production mix is lower than before, in this case. You can see it directly here because this one expected was 250, if I remember correctly. This was lower, this is lower, this was lower in the end. Okay, we waste some time here and there. Now, what is left on production capacity? How we can use to estimate capacity for the next year? How we can use it? The point is that we know from the past, and we are able to calculate, which was the production mix of last year. Standard. Okay? We know the opening calendar time in the past, if you want. Now I'm looking at the past. we can calculate which is the utilization. We have it. We are able to calculate the efficiency. We are able to calculate the effectiveness or the quality yield, whatever you want. Okay? That we have in the past. And we use all these indicators to understand what has happened. Okay? Now, I look at the future. PMix, is PMix going to change or will remain the same? If the PMix will remain unchanged, I can use the same PMix standard. If I will make some training and will reduce, I will increase, the production standard rate of product 1 and product 2, or only product 1, I have to recalculate the new PMix to be used next year. Okay? T, I know from the calendar time. I subtract the holidays or whatever. Utilization, I look at utilization. Maybe I will not make any intervention. So I can take utilization, okay, and I can project utilization in the future. Use the same utilization of 2025 for 2026. But excluding lack of material and lack of organization. So utilization will increase a little bit in case. Efficiency. What was the efficiency? Efficiency, the point is, we can keep on working the same way, or we can increase the efficiency. Again, training, changing machines, whatever. And now we can use the ones. So we have to decide if the past data can be reused or not. The ones that can be reused can be projected. The effectiveness, 98%. Are we changing something on machinery in order to increase the quality yield? No. The idea is that we can expect to have the same results, or maybe lower, a little bit lower because of obsolescence of machines. Okay? And so, indicator by indicator, we can to some extent understand, forecast the future capacity. Just to better understand, this is standard mix. This is opening calendar time. So this one multiplied by this one, so PMix standard by opening calendar time. This is the theoretical maximum that I can obtain from my plant if I respect all the standards, time, and if I don't have any loss. Okay. Okay. After that, I multiply this theoretical capacity by productivity. Productivity is given by utilization multiplied by efficiency. If you want, utilization is going to reduce opening calendar time, and efficiency is going to change standard production mix. Okay? Instead of 250 days, I will have 90% of 250 days available for producing. Instead of, I cannot remember, 775, efficiency will reduce this one to 658. Efficiency can increase, okay, in case. So if you want, this is the theoretical capacity. This is the productivity that is going to reduce this theoretical capacity. This one multiplied by this one will give us how many units I'm going to produce. But only when I multiply by 1 minus the effectiveness, I will know how many unit compliant I'll be producing. So this is the maximum that I can produce, time by speed. Okay? This is a reduction of the time, this is a multiplication of the Pmix, and this is a reduction of the, in terms of rejected, so how many good units I'm going to produce. Okay? Some other, define also utilize standard capacity as Pmix multiplied by Pmix standard multiplied by opening calendar time multiplied by utilization. Okay. Some other define Pmix multiplied by, this is something related with opening calendar time, but it's not, multiplied by availability only, it's not utilization. That's why this cannot be opening calendar time. When we can use this formula, when all the losses but failure and maintenance are not significant. So here I'm assuming that availability is equal to utilization. This means that all the losses but failure and maintenance are not significant. Okay? But this is only happens when I got single machine production line automatized. Otherwise, I have to put here utilization. This one. Okay? But somebody will push you to use this one. You have to check that lack of material, organizational strikes are, to some extent, not important. Otherwise, you're making wrong calculation. Okay? Sorry to, I also present you not wrong, but not perfectly right situation that you can find in real companies, okay, that happened to me. Okay? Now, what happened with OEE? The same. OEE has been developed in for particular production systems. I would say that the situation is very similar to this one. Okay? And the idea is that you have the Pmix standard multiplied by this T that is not the opening calendar time, but is planned production time. Please remember the difference. Planned production time is opening calendar time minus the strikes, lack of orders, time for maintenance, and time for trial and test. After that, you have to multiply by availability, performance, and quality OE indicators. And you obtain good production. Okay? Again and again and again, this is, to some extent, applicable, adoptable only under the verification of assumption. Okay? Last, and here I'm going to stop, is about the Hamlet question that I told you before. Okay, every time you have to estimate the capacity of a production systems, you have to ask the question, which is the zoom in I'm going to do? Okay, because it's quite different to understand which is the capacity of a single machine, a set of machines in a line, and the whole system. Likewise, the calculation of availability that we make last year, please remember that is obviously is better that all machines have the higher capacity. But there is also a matter of how they are linked together. Because in a production line, it's enough to have one machine that have a very low capacity, that the whole system will perform with low capacity. Okay? It's not said that when all but one, the machines within a production line have a high level of production capacity, the whole line will have a higher production capacity. This is the point. Okay? Not only, please remember that if you have different means of production, labor together with machines that are considered together, if you have good machines, capacity machine, but you don't have, to some extent, the same trained, skilled labor over all machines, the system will not go at that speed. No way. So please reflect that. We will be back. Okay? 2 minutes late, but more or less on time. Any question?
Is the exam open book?
Huh? You didn't read. No, go back and listen to the recorded lesson and see the slides. It is written that the exam is composed of the written exam is composed of 2 parts. One is related with open question, closed book. Exercise part, open book. But open book means that you can take books, physical books, notes, whatever, but not notes on tablets or that are communication devices in the end. So we cannot jam communication, so we can not let you have those ones in class. Okay? If you have any question, please ask. I'm here. Sorry, I forgot to tell you. Maybe I told you, maybe I'm not remembering. You will receive, I think, an email, and some additional material will be uploaded by Professor Lero. Maybe I told you. A second part. Anyway.